Hi there, this is Mr. Sand. We're going to be talking about phases right now. You might remember what the different phases are um, from, like, I don't know, from your earlier days in, like, elementary school. For water, there are three common phases that we use for that we talk about for water. One of them is a solid, one of them is a liquid, and the other one is a gas. When you go from solid to liquid, there's a process called melting. When you go from liquid to gas, it's called boiling, also known as vaporization. If you go from gas to liquid, it's called condensation. Just say COND, condensation. Yeah. And then if you go from liquid to solid, that's called freezing. And then scientists use this word called fusion. Okay. So, vaporization and fusion are going to be key terms when we talk about these changes between solid, liquid, and gas. But what is a solid? You might be wondering. If you look at something that's like, let's just represent water molecules as these like little dots here, because we haven't really talked about chemistry. Water molecules, if they're little dots, they're moving all around each other when they're in the liquid phase. So water, as it's liquid, these things will be moving over each other, slipping past each other, and just sliding past. They'll be moving all about themselves. If you've got a container that they're held in, which has very rigid molecules, then these little sliding, if this is a different kind of molecule that's holding these water molecules in place, it could be bigger or smaller than these water molecules. So probably they don't have any gaps in between them. Otherwise, it would be leaking. But this right here, these little ones inside here, these are the water molecules, and they're slipping past each other, and they'll just take on whatever shape the container has. Okay? Their overall shape will be whatever this container is. So this right here is a liquid, obviously. Okay. Now, this is a liquid. Well, what's a solid then? Well, a solid would be if these water molecules then arrange themselves. They lose their energy to a point where they get locked into place. They get locked into a very orderly place. So this would be something like an ice cube. These water molecules all stack together very tightly. It's funny when you look at the structure of water, the liquids phase, at least for some types of water and some types of ice, the liquid phase is more tightly packed together than the solid phase. They actually kind of spread out in a rigid structure. But the main idea about solids is that they are very, very regular structures, and they're rigid. They're somewhat rigid. What rigid in here? Here, they're not structured. They slide past each other. Okay, and then finally for gas, you can guess what gas is going to be like. Very spread out. These things are all over the place. These are water molecules that are just very, very spread out, very far apart from each other. And that's really the big difference between solid, liquids, and gas. These things are very, very spread out. These are closer together, and these are very tightly packed. Normally, this is how matter behaves. Sometimes you've got this, like, water is actually a strange kind of example here because the regular structure here is a little bit more spread out than these. But it's very regular and it doesn't move. It's kind of locked into place. And that's why ice floats on top of liquid water. Anyway, we got solid, liquid, gas here. We got the changes between those three phases. There's also a phase change from a solid to a gas and a gas back to a solid, but we won't really concern ourselves with that here. What we will concern ourselves with are two types of heat that water gains or loses. There's two types of heat. One type of heat is called sensible, and the other one's irrational. Just kidding, it's not irrational. Sensible, and the other one's called latent heat. Latent heat. Okay, latent heat and sensible heat. They both are heat, so they both use Q, but they have different equations here. Let's use different colors. So for sensible heat, this is the stuff that you normally think about. This is where you have a mass of some material, you have a specific heat, and it's got to change the temperature. For latent heat's really weird, because latent heat is just as a mass, but they've got this big abbreviated thing right here, an L. Let's see, L. L is latent heat, but that doesn't really give us any information. Latent heat is the heat that's absorbed. Heat absorbed or released / released during phase transitions. So in other words, there's no temperature change during these phase transitions. So when you're going from a solid to a liquid, the temperature gets raised to a certain point. When it's getting raised to that certain point, that heat that's being put into that solid is sensible heat. As soon as it gets to that point in which it melts, well, all of that heat that melts that solid then, it doesn't change the temperature of that solid. You're shocked, maybe, I don't know, but it's true. Once you get to the solid to a certain temperature, you can't raise its temperature anymore. It will just, all the heat that you put in will just change that solid into a liquid. That changing of a solid to a liquid is that latent heat that you're putting in. And so that's the heat absorbed in this case during the phase transition. There's no temperature change. And if it was going from a solid to liquid, we call that the latent heat of fusion. But there's another latent heat. It can be latent heat of V, which would be vaporization. So that's where these came in, right here, fusion and vaporization. Okay, so if it was liquid to gas, it would be vaporization. If it was solid to liquid, it would be fusion. Right, now if it's liquid to solid, it would still be fusion. It would just be in the opposite direction because the heat would be giving off, the heat would be given off from the solid. I'm sorry, let me start that up again. If it was going from liquid to solid, the liquid would be giving off heat. And so this would be a negative number. And likewise, if it was going from gas to liquid, this would be a negative heat as well. Okay, so where have we seen this before? We've probably seen this in these little graphs that the teachers make you do, where you've got temperature on this side, on this axis, it's going up, and you've got heat added on this side. It's usually measured in time. They don't really give you a amount of heat, but you've got like a burner, and you've got, let's say, some ice, some solid ice, and you just keep on heating up that ice. So let's say that we've got ice, and it starts at a very low temperature, below 0. So let's say that this is 0, and let's say this is 100 degrees Celsius. This is 0 degrees Celsius, and that's 100 degrees Celsius. So if you add heat to water, the temperature will raise, and then it'll flatten off. It'll flatten off for a long time. And then it raises again. Steep raise. And then it flattens off for a very long time. And if you keep it on the burner still long, it'll eventually go up even more until it goes to the other phase transition, which is plasma, but we won't get to that. This, I had to sneeze. I'm okay. Going from here to here, that heat that's added, that's sensible heat. Because how do you know that? You know that because sensible heat is the heat that you put in when you're changing temperature. Okay? Now from here to here, we use a different color. I'm going to use green. So from here to here, this little chunk of time right here, the amount of heat that's added is latent. Notice that there's a lot more latent heat that is added versus sensible heat. That's always true. It's kind of weird too. Over here, again, this is the heat that's been added is all latent heat. And right here, that's sensible heat. Okay. So if you want to measure how much heat has been added to something, if it goes from, like, let's say this temperature right here, let's just put a random temperature. Let's just say it goes from, let's say this is like negative 20 degrees Celsius. So at negative 20 degrees Celsius, if you want to measure the heat that's absorbed by something, if it goes from negative 20 degrees to, let's say it's 80 degrees Celsius, you're going to add up the heat that's added, and so you're going to have to use sensible heat here and here, and you're going to have to use latent heat from here to here to get all the heat that's been added that makes this sample from 20 degrees, negative 20 degrees, up to 80 degrees. Okay? So what you'll have to be doing there is you'll have to be using Q equals MCAT for the sensible heat, and you'll have to be using Q equals M, and then this is going to be changing from a solid to a liquid, so it'll be LF for latent heat. And over here, you're going to have to use sensible heat again. Q equals MCAT over here. All right. And you'll be adding up all of these heats together. So you'll be adding the sensible plus the latent plus that sensible to get the total amount of heat that's been added to the sample. All right. So let me give you an example. Let's look at warm-up problem number 1. Warm-up problem number 1.